Hello everyone, this is Ryan Chan. This is Professor Chan for Math 1240. I'm going to kind of go over this concept called hypothesis test. Okay, make sure you do look at the prior videos and the prior PowerPoints. I'm going to show you some examples. Okay, so hopefully you guys kind of look at the notes for hypothesis testing. So the idea is, remember, when we do hypothesis testing, you have two hypothesis. You have what's called a null, which is H naught. Okay, this is called null, and then you also have alternative, which we call HA. Okay, and you have a 0 for the subscript for null, and you have a for the subscript for alternative. Okay, so sorry, let me zoom in. Okay, and one thing is, actually, let me just insert a new page. Okay, so one thing is when we do null, H null, okay, the idea is it's always going to be P is equal to, okay? But then when I have alternate, it's either going to be three symbols, either going to be less than, greater than, or not equal to, okay? So null is pretty easy. It's always going to be P is equal to some number or some percentage, okay? And then my alternate is going to be either one of the three types of inequalities, okay? Less than, greater, not equal to. And the idea is your null and your alternate contradicts each other. So the idea is what your null and your alternates are is you have two arguments, okay? So for example, like you could say your null will be like we would have someone claim that 30% of everyone likes chocolate milk, okay? And your alternate would be someone saying like, no, I think you're wrong. It's less than 30%, or it's more than 30%, or it's just not equal to. So if you notice, all three of these um, inequalities, right? So remember, this one is called less than, this is called greater than, okay? And this is what's called not equal, okay? Essentially, all three of these contradict with my null, right? Because my null is saying P is equal to, and the other ones are saying no, they're not, okay? So how do we write this out? Okay, so we're going to do some quick warm-ups here, okay? And then we'll start doing some actual problems, okay? So before you start, you must know how to construct your null and your alternate, okay? Because if you screw up, then unfortunately everything else is everything else just kind of falls apart, okay? So let's take a look at this, okay? So one of the things is we have to figure out which one is P, okay? So remember, P is population proportion. So that is 30%, right? Because that's the percent for all college students, right? So remember, P represents a percentage out of everyone. So my null is going to be P is equal to 0.30, okay? So now, how do I find my alternate? Your alternate, a lot of times they just give it away to you. Generally, it's the last sentence. So if you notice, it says, give the null an alternative hypothesis test that the dropout rate is not 30%. So the not, that means I'm going to use the not equal sign, okay? And that would be my answer right here, okay? So let's also talk about something in particular, okay? Your null and your alternate will always be the same number. So notice my null is P equals 0.30 or 30%, and my alternate is P is not equal to 0.30 or not equal to 30%, okay? Right? It doesn't make sense for me to say like P is equal to 12% and then I say P is not equal to 13%. Do you guys follow me? Because then I'm not really contradicting myself, right? I want my two claims to contradict each other. So null is always equal to, and alternative is one of the three, but always has to be the same number. Okay. Let me give you another example here. Okay, so it says number 2, it says, according to Time Magazine, 33% of all cars, so this is a big giveaway, that is P, right? Because it's all, right? Percentage that represents all. So my null, or H0, is going to be P is equal to 0.33. Okay? Now notice it says, what is the null and alternate hypothesis to test at fewer than 33%? Okay? So fewer implies less than, right? So my alternate will be P is less than 0.33. Notice I use the same number, okay, as my null. Okay, the only thing different between my null and my alternate is my symbol, right? I have equals and then less than. But notice my letter is the same, it's still P, and my number is the same, which is still 0.33. Okay. Okay. So that's how we set it up, okay? And you want to make sure you get your null and your alternate correctly, okay? And the alternate, they always kind of give it away in the question. I'll show you more examples of that. But if you screw up your null and your alternate, essentially you're just gonna mess everything else up in your problem. So the biggest takeaway for chapter 8.1 and 8.2 is you must establish your null and your alternate correctly. Okay? So yeah, so we're gonna do a couple of these. And then if you have questions, feel free to ask me more. Okay? Because yeah, these can get a little tricky. Okay, there's many parts of the problem. Okay, so it says we toss a coin only 50 times and get 22 heads. Is this evidence to suggest the coin use is not fair? It says state the null and alternative. Okay, so this one's a little tricky because they actually don't give us P, but we have to realize if we use common sense, okay, that if I flip a coin, right, it's always going to be 50% heads or tails, right? So theoretically, right, if I flip a coin, it should be 50%. So my null is going to be P is equal to 0.5. And then notice it says that coin use is not fair. That's a big giveaway. And so my alternate will be not equal to, okay? Some of you guys are like, why can't I use less than or greater than, right? If it was less than or greater than, they would say something like fewer than 50% or greater than 50%, right? And that would change my symbol, okay, for the following. Okay. So let's talk about this here, okay? So so my mean is actually just P. And then my standard deviation, if you remember, is my standard error, which is equal to square root of P times 1 minus P over N. Or in this case, square root of 0.5 times 1 minus 0.5. What is my N? My N is equal to 50, right? Because I have 50 trials. And this is approximately 0.0707. Okay? So this is my standard error. Okay? Okay, and then let's also talk about what else we have. We toss a coin 50 times to get 22 heads. This is a proportion, but remember this is P hat. Okay. Okay, so let's talk about what's the difference between P hat and P, right? Remember, P hat is sample proportion. So notice I flipped a coin 50 times, I got 22 heads. P is 50% because that's the percent for all coin tosses, ideally. Okay, so make sure you know the difference between P hat and P, okay? Please practice that. You want to make sure you know the difference between your sample proportion and your population proportion, Okay. So what we're going to now do is we're going to do the standard score for the data. I'm going to use z is equal to p hat minus p all over se. Okay. So we've done this before. Actually, this was in chapter 7.3, right? We're actually just doing central limit theorem. Okay. So I have 0.44 minus 0.50 divided by 0.0707. Okay. So I have here, so I'll put this in parentheses, or I'll just combine it first, 0.44 minus 0.5, and I'm going to divide it by 0.0707. I'm going to round two places over, and I have negative 0.7929, okay? Oh, sorry, negative 0.44 minus, sorry, 0.4 minus 0.5. Sorry about that, guys. Okay, this is, sorry, negative 0.85. My apologies. I'm running two places over, okay? So let's talk about what we're doing. What am I doing here? And remember, there's two ways, okay? Remember, you can do it by hand or you can use your calculator. But idea is, let's understand what's happening, okay? So I remember you have your normal distribution curve, okay? What goes in the center? That's 0.50, right? That's your P. And we're going up by 0.0707, okay? So we're going 3 to the right and 3 to the left. Okay, so let's talk about this. So we're trying to figure out when it's not equal to 0.50. My z-score is negative 0.85, which is here. And I'm also going to go here. Okay, now this is where it gets a little confusing. Some of you guys are like, why am I shading both sides? Okay, well, the reason why is because your alternate is not equal to. Okay. So remember, not equal to is two-tailed, okay? So let's talk about this right here, okay? So if it's not equal to, remember, if it's two-tailed, let's talk about this. So if it's two-tailed, remember, this is all the way back in chapter 6. You would do either 2 times the table of the left, okay? Or 2 times 1 minus the table of the right, okay? Now let's think about this, right? We're doing the negative 0.85, so we're actually doing this one. So we'll do the 2 times the table of the left, okay? So this is 2 times, I'm going to look up my table for negative 0.85. Negative 0.85 is 0.1977. And I multiply it out. And I get 0.3954. Okay. So what is this saying? This is 0.3, this is 39.54%. That's actually the area of both of these. Okay. For the following. Okay. So I know this is a little confusing so far, right? So, but the idea is part B to part D is essentially you're doing central limit theorem, right? You're trying to find an area underneath the curve, okay? Which is what we've been doing. And then you shade, right, based on your alternate, okay? So let me talk about this right here, right? So the idea is we're trying to see if I get 22 out of 50 heads, if it's not fair, right? If it's really fishy. So the answer it's telling us is that we have a 39.5% chance of this happening. So that's actually a relatively high percent chance, right? If it's smaller, okay, if my area or my percentage is smaller, the percentage under my area is smaller, that means it's less likely to happen, okay? And in your notes, we use something called the level of significance, okay? Now, they don't tell this, so this problem here, they don't tell you, okay, for the following. So you assume that your significance level, okay, if they don't tell you, is 5% or 0.05, okay? So what is my p-value? My p-value, or the area underneath my curve, is 0.3954, which is greater than 0.05, okay? So because of that, we say the following. We do not reject null. And we say there is strong evidence. Oh, sorry, there is not enough evidence. Oh, sorry, my bad. There is, sorry, let me redo that all again. There is enough evidence for the coin to suggest it, for the coin to not be fair, okay? So where am I getting that from? Okay, it's always generally the last part of your question. So the question part is actually your alternative. Okay, that's it right here. Okay, so take a step back, look at the problem. You'll probably have to pause this video. Okay. So remember, this video here is just extra additional practice. You want to look at the actual PowerPoint to do this for the following. Okay. So, okay. Now, let me also talk about this. So some of you guys are probably really thrown off by the whole shading part, okay? So the idea is, if you remember all the way back in chapter 6, okay, is if your alternate, right, let's think about this. If your alternate is less than, right, less than means your area goes to the left, right? So it's like this. So that means your percentage, right, is your table. If your alternate is greater than, that means it's going to the right. Now remember, based on central limit theorem and in chapter 6, that means this is my percentage. Sorry, my percentage is going to be 1 minus the table. Okay? And then if my alternate is not equal to, right, I have a two-tailed situation. And this is going to be either 2 times whatever my table is. Okay. This is if my z is negative. Or 2 times 1 minus the table. And this is if my z is positive. Okay. So this is why your alternate is important, because ideas, it dictates kind of what's going to happen for the following. Okay. So let me show you another example right here. Okay. So it says, do our athletes graduate? The National Collegiate requires colleges to report the graduation rates. Okay. 73 out of 117 are admitted. Consider these athletes as a sample of all athletes who will be admitted under the present policies. Is there evidence that the percentage of athletes who graduate is less than 71%? Okay. So here's a thing too. Your alternate kind of gives it away, right? This is, okay. Hypothesis, here's a trick too. Hypothesis tests always ask you, is there evidence or can you verify? It's something to that vein, right? So if you see that combination of is there evidence or does it verify, that implies hypothesis testing, okay? So I'm gonna first test, right? I'm gonna do H naught is P is equal to 0.71. And my alternate is P is less than 0.71, okay? Where I'm getting that from, right? I'm getting that from right there, right? It says it's less than, okay? So that's a big giveaway, okay? So the first part is you always establish your claim, okay? Remember, P is always equal to, and your known alternate will have the same number. Okay. So the second step is I'm gonna start compiling my other parts of information. Okay, so I have P hat. P hat is 73 over 117. Why? Because this right here, 73 out of 117, right, that's a sample. And literally, actually, they just said that right there. Okay, let me erase that. Okay. Okay. So I'm going to put this in my calculator. Okay, I'm going to go 4 places out. And then remember, I need to also find my standard error. So square root of P, 1 minus P over N, or in our case, square root of 0.71, 1 minus 0.71, divided by 117. Okay, so I'll take the square root. And I'm getting 0.0419 or 0.0420. I'm gonna round up, okay? So I have my P hat and I have my standard error. Okay. So let's talk about what's happening, right? So let's look at our curve, right? Our curve looks like this. Okay? For the following. So idea is, right, my P is 0.71, okay? Okay? And then I'm trying, and I notice, right, I have my P hat, right? So my sample that it gives me is 0.6239, okay? And if I subtract, right, okay, I'm not going to do this all the way. You guys should know this, right? Remember, you're adding, subtracting 0.0420, right? Because that's your standard error, okay? So 0.6239, right, if you're going by 4.2% each time, let's see, so that's like 0.67-ish, and that's like 0.62-ish, right? So actually, it's going to be a little bit below, and 0.6239 is here. And since we're going less than, we're going to go to the left, right? So I'm actually shading this area. So I'm trying to find this area right here. Okay? So since my alternative is going to the left, right? And it's less than, I'm going to use my z-score. So I'm going to z is equal to 0.6239 minus 0.71 divided by 0.0420. And I get approximately negative 2.05. And remember, since it's less than, you'll just use your table. So I'm going to use my table here. And if I look at this right here, sorry, let me scroll down. See, negative 2.05. I get 0.0202. So my table gives me 0.0202. Okay, now, here's a thing to remember, right? If you don't like doing it by hand, remember you also have your calculator. You can still use normal CDF, okay? So, sorry, let me scroll down. Okay, so remember, you can also do this. I can do or, and remember I can do normal CDF, right, in my calculator. Okay, now if I look at the picture, right, and this is why you want to make sure you graph your picture. You can graph the picture here, and you want to see it goes from smallest to largest, right? So my smallest is negative 1 E99. My largest is 0.6239. My mean is 0.71, and my standard error is 0.0420. So I'm going to put this in, right? Second vars, right? Normal CDF. So negative 1 E99. Normal is, upper is 0.6239. Be very careful. Your mu is actually going to be your P this time. This is going to be 0.71. And then my sigma is my standard error. And if you notice I get something really close, I get 0.0202. Okay? Okay, so let's talk about this, okay? Okay, so either way, my p-value is going to be 0.0202, okay? So my significance level is going to be 0.05. My p-value, 0.0202, is less than 0.05. So I'm saying, what am I saying? There is a 2.02% chance that essentially 71% of all students who graduate within 6 years. So the idea is, based off of my report, right, I had to, so let's talk about this, right? So the idea is, someone initially makes a claim that 71% of all students graduated within 6 years. We did our results, and there's a 2.02% chance of that happening. So that seems very unlikely. That's less than 5%, so we say we reject null. Okay, it's a two-part. So the first one's either you reject or do not reject null. Okay, and the second part is whether there's strong evidence for your alternate or not enough evidence for your alternate. Okay, so because we reject null, we say there is enough evidence that the percentage of all athletes who graduated is less than 71%. Okay? That would be my final answer right here. Okay, so I know this video is going to be a little bit on the longer side, okay, but I just want you guys to show, I want to show you a bunch of different ones here. Okay, so let's look at one more example. Okay, so let's look at this one, number 4 here. Okay, it says a team of eye surgeons has developed a new technique for a risky eye operation to restore the sight of people blinded from a certain disease. Under the old method, it is known that only 30% of patients recover their eyesight. Okay, can we justify the new method is better than the old method? Okay, so this part is a little tricky here. So it says new method is better than old method. Okay, and you're like, what do you mean by better? Well, it depends what we're talking about. So when we're talking about method, we're talking about which method ends up having a higher percentage of patients recovering their eyesight. So if it's better, right, that means more people or a higher percent recovers their eyesight. So that means my alternate will be greater than. Okay. So 30% is everyone. So that is P. So my alternate is P is greater than 0.30, and my null is P is equal to 0.30. Okay? So make sure you understand that. Again, if you have questions, let me know. Okay, so the second part, we're going to find our P hat. P hat is 88 over 225. Put that in my calculator. Sorry, I'm going to be doing the calculator outside the screen, but you can follow along. That is 0.3911. And then my standard error is going to be 0.3, right, times 1 minus 0.3 divided by 225. You should get 0.0306. Okay, and one thing is when you're calculating your standard error, try to do this, try to follow along and see if you guys got that for the following here. Okay, so let's talk about what's happening here, right? So if I graph this, in the center is 0.3. My sample, remember, is kind of where it's shading towards. So my sample is 0.3911, or my P hat, okay? So let's talk about this here, right? And I'm going up by 0.0306. Okay, I'm going to do a rough approximation, right? So idea is, right, this is like 0.33, 0.36, 0.39, right? Because I'm going up by 0.0306, okay? Right, so remember, every single time I go up and down, I'm adding, subtracting 3% in this case. So 0.39 is here, like 0.3911, and I'm going to the right because it's better than and my alternate, right? So remember, since my alternate is greater than, this time I'm going to the right, okay? It also means my p-value is going to be 1 minus table if I'm doing this by hand, okay? So if I'm doing it by hand, let's take a look at the third part, right? Remember, it is P hat minus P over SE. So my P hat is 0.3911. My P is 0.30. My SE is 0.0306. I'm going to use my calculator. So 0.3911 minus 0.3 divided by 0.0306 is approximately 2.98 for the following right here. Okay. So that is my z-score, right? This is my z-score. So I'm going to use that to calculate my table. So let's go to my z-score. So 2.98, right? According to my z-score. It is, according to this here, 0.9986. It's this one right here. Okay. And since it's greater than, right, my p-value is going to be the following. It's going to be equal to 1 minus, actually, was it? Sorry. Did I mess up? No, I didn't. Okay. Yeah, so it's 1 minus 0.9986. And this is 0.0014, okay? Now, if you don't like that, remember you can use your normal CDF, okay? So let's talk about this. You can do normal CDF for all three for less than and greater than. If you have not equal to, remember, you just do normal CDF for one of your sections and then multiply it by 2. Okay. So my normal CDF, right? If I look, if I look at my curve, right? What's my smallest? My smallest is 0.3911. That's where my shading begins. My upper is 1E99. My medium, my middle is 0.30, and my standard error is 0.0306. So second vars, do normal CDF, right? Watch what I'm typing in, 0.3911, 1E99, 0.30, and 0.0306. So you see, I mean, I'm off by a tiny bit, but that's not beside the point, okay? So, but it's pretty close. So if I use my calculator, I have that. Okay, and remember, you can do either one. You can do it by calculator or you can do it by hand, right? This is exactly the same thing we talked about in chapter 6 and in chapter 7, okay? So what does that mean? So we're saying the chances of this likely happening, that 30% of people recover their eyesight, there's a 0.0015 or a 0.15% chance of happening. That seems very unlikely. So part 4 is we make our conclusion. So our conclusion is this, right? We notice that 0.0015 is less than 0.05. So since that's not likely, we're going to reject null. And then we say there is strong evidence that the new method is better than the old method. Okay, so in this part here, right? And so the idea is this last sentence kind of highlights that for the following here. Okay, so that's pretty much it. Okay, if you have questions, okay, I know you guys probably will. Feel free to respond in the discussion. Okay, please practice all the stuff from chapter 6 to 8. Okay, it's gonna be really important because everything just kind of builds. So you want to make sure you understand stuff with like normal CDF, inverse norms. You want to practice all these as you kind of go along, okay? But other than that, I'll see you guys later. Make sure you do your assignments that are due on Tuesday.